Today we're talking about completing the square of a quadratic equation. Basically, you complete the square. It allows you to always put a quadratic equation in some sort of factored form. So, if we just jump right into it, if we have x squared plus 2x plus, let's say 7. Okay, this isn't going to factor if you try it. But you could still complete the square, and the idea is to the procedure is to take this middle term, the one with the x on it. Well, first you need to make sure this coefficient in front of the x squared term is 1. If this was like a 3, you would divide by 3 through the whole thing. You would make sure it's 1 or factor it out. So in this case it is 1. So the next thing to do is to look at this middle term, and which is the 2x term. Take the coefficient in front of it, 2, and then divide it by 2, and you're going to get 1. Then you square this term, and you're going to get 1. So now what you do is you take this term here, 1, and you add it and subtract it at the same time, because the idea is to not change the equation. If you add and subtract at the same time, then you're not changing it. The other thing you could do is add 1 to both sides, like that, but it's the same thing. I like to add and subtract on one side. So basically, yeah, you'll see. So now we have this. We're just gonna rearrange these numbers a little bit. I'm gonna move the 7 right here. And what happens is these first terms always factor. They're gonna factor. It's gonna factor into x plus half of the middle term, which is 1. X plus 1 squared. And then you're going to have plus 7 minus 1. But plus 7 minus 1 is plus 6, so equals 0. So that's the equation when you complete the square. Excuse me. So basically, what happened here basically is you force from these two terms in the front. You basically add another term in that allows the first 3 terms to become a perfect square trinomial, which you can factor in by conventional methods. Like I said earlier, an easy shortcut into factoring this is that you know it's going to be a perfect square, so you can just put x plus half of this middle term. That's what's always going to happen. Or you can do the whole factors of 1 that add up to 2, which is going to be 1 and 1, so x plus 1 times x plus 1, so x plus 1 squared. You're basically working backwards. Like if I were to FOIL this, it's basically backwards foiling. So let's do another one. How about if we switch this up and make this 3x squared plus 9x plus 12, something like that. So remember, first step is to make sure the first term is 1. So I have a couple of choices. I can divide by 3 on both sides. It's not going to matter. I can factor it out. Usually you factor it out because it might be in another light where you can't divide on both sides. But so you factor it out. 9 divided by 3 is 3, and then 12 divided by 3 is 4, and there you go. So now you do the same thing. You take this middle term right here, this 3x, divided by 2. Let's over here. So you divide it by 2, so you get 3 halves, and then you square it, so you get 9 fourths. Okay, so now you can't drop this 3. You need to bring the whole thing down. That's very important. Now, after the second term, you add and subtract 9 fourths plus 9 fourths minus 9 fourths. You always add and subtract this term here after you've squared after you've squared it. Well, after you've divided the middle term by 2 and then square it. So that means that these three terms have to be a perfect square trinomial like we had before. But I mean, if you were given this, if you're not the best at factoring, you might say, oh man, this is kind of tricky, there's a fraction in there, you know, what am I going to do with this 9/4? But you know that these first three terms have to factor into a perfect square. So, because that's what this whole method does. But basically, remember my shortcut. Basically, you just take this first three terms, take the first three terms, and it's going to be x plus something squared. But remember that plus something is half of the middle term, which is 3/2. So x plus 3/2. And if you FOIL this out, you will indeed get these three terms right here. You can check that for yourself. So now we just have to add these two together. And remember, when you add to the, if I might step back for a second, when you add, you remember to add inside the parentheses. Do not add outside the parentheses, because you would have to multiply them by 3 in this case, and it's just more confusing. Add inside the parentheses, remember. So now we've come back to this. We have to add these two fractions together. Well, 4 is actually equal to 16/4, and then 16 minus 9. Let's get rid of this. Over 4, 16 minus 9 is 7, right? Because 9 plus 7 is 16. And was it a plus? Let me. Yeah, it is a plus. Plus 7/4. Yes. So now we could bring this 3 in. Let's see. Well, bring the 3 in. It's going to be 3, and then 7 times 3 is 21. And there you go. That's your when you complete the square. That's what you get. So that's pretty much it. You pretty much need to remember certain rules, and that is, first you make sure that this first coefficient is 1 by factoring out whatever is in front of it. In this case it was 3. Then you take the middle term, divide it by 2 and get 3/2, square and get 9/4. Then you add and subtract 9/4 after that second term. Now, these first three terms are going to be a perfect square trinomial. You factor in the shortcut way. Just say x plus whatever this middle term was. So x plus 3/2 squared. Remember, don't forget that squared. And then plus, you add these two together. Then you can bring in the 3, or whatever you factored out, and that's pretty much it. They all work the same way. If you just do a bunch of them, you'll be fine. Thanks for watching.